Hi there, I'm Alvin, a researcher from the Advanced Manufacturing Center, or AMCen. Most of you might be wondering, what is 3D printing? 3D printing is building an object layer by layer from a chosen material based on a digital model. Sounds interesting, right? If that's the case, stay tuned for the rest of the video because I will be discussing what are the basic steps in 3D printing, why do we use 3D printing, and what are the 3D printing capabilities of AMCen. The basic steps in 3D printing are: first, we would need a digital model. We could generate a digital model by using a computer-aided design software, or also known as CAD, then convert it into an STL or any slicing software readable file format. We could also download a digital model online, then convert it to STL or download it directly as an STL file. Next, we'd be using a slicing software. We would slice the file to provide the toolpath, parameters, and commands to the 3D printer. It is then converted to G-codes or a similar format. Next, we upload the codes to the 3D printer. It could be uploaded via USB, Ethernet, or Wi-Fi. This will depend on the 3D printer that we would be using. Next, we select the file and start the print. Here comes the most exciting part of 3D printing: waiting for the print to finish. Once the print is finished, it might or might not need post-processing. This would depend on the printer that we use, material that we use, and the intended design output. So that covers the basic steps of 3D printing. The simplest reasons to use 3D printing are faster design iteration, faster prototyping, and creation of objects with complex geometries, which is difficult or almost impossible to be done using conventional manufacturing techniques. With these aspects, we could think of 3D printing as an innovation that drives more innovation because of the limitless potential of outputs. So the biggest question is, can any object be 3D printed? The short answer is yes, but certain criteria, such as print size, material to be used, and application of the printout should be considered. AMCen has 3D printing technologies for different materials and different sizes. One of these technologies is the Fused Deposition Modeling, or FDM. It is the most common type of 3D printing. In this process, a material is extruded through a heated nozzle, which builds a layer as it moves along the heated build platform. Once a layer is done, the nozzle moves up and builds the next layer. The process repeats until the print is finished. AMCen has FDM printers for commonly used materials such as ABS, PLA, PET, PETG, and PC. These materials may be in filament or pellet form. AMCen can print not only small and medium-sized objects, but also tall and large ones as well. Here are some sample prints. AMCen also has the capability to print high-performance polymers such as PEEK, PEI, and PEKK. These materials require higher temperatures and are stronger than common FDM materials. And that covers FDM. Stereolithography, or SLA, is the oldest 3D printing technology. This process converts photosensitive liquid into solid objects, layer by layer, using a laser and photopolymerization. AMCen has two types of SLA printers, a bottom-up SLA printer and a top-down SLA printer. Let's start with the bottom-up SLA printer. The process starts with the build plate moving down to make contact with the resin within the tank. Underneath the tank, there is a UV laser. The UV laser cures, solidifies, and builds a layer. Once a layer is done, the build plate moves up and the UV laser cures, solidifies, and builds the next layer. The process repeats until the print is finished. AMCen has a wide variety of homogeneous resins to choose from, such as standard resins, clear resins, draft resins, engineering resins, dental resins, and castable wax resins. And here are some sample prints. Next is the top-down SLA printer. In this process, paste is stored in a reservoir tank. A blade sweeps the paste from the tank onto the build platform uniformly. A laser positioned above the build platform cures, solidifies, and builds a layer. Once a layer is done, the build platform moves down and the blade sweeps a fresh layer of paste onto the build platform. The laser cures, solidifies, and builds the next layer. The process repeats until the print is finished. The printed object undergoes post-processing techniques such as debinding and sintering. We use this 3D printer for ceramics such as zirconia and hydroxyapatite. Here are some sample prints. And that's it for SLA. Direct metal laser sintering, or DMLS, is used for printing metals in powder form. The process in printing is almost similar to the top-down SLAs. Direct metal laser sintering, or DMLS, is used for printing metals in powder form. The process in printing is almost similar to the top-down SLAs. The significant differences are that instead of using paste being spread uniformly on the build platform, we would be using metal powders. And instead of using the laser to cure the material, the laser is used to fuse the metal powders. The printed object is subject for post-processing techniques such as heat treatment, shot peening, surface finishing, or machining, depending on the intended design. Here are some sample prints. To recap, we discussed the basic steps of 3D printing, the reasons for using 3D printing, and the available 3D printing technologies at AMCen. If you have any 3D printing questions or requirements regarding your research, prototype, or commercial product, AMCen is here to assist you. We know that 3D printing technology is still evolving. But don't worry, AMCen is keeping in step to forge new paths for our country's progress. And that will be the end of this video. Hoping to see you in the next one. And don't forget, let's go beyond the conventional.